Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to continue on our syllabus, chapter number 3, Introduction to Probability. Right. So last class we already look at on counting rule, right? And then we already look at the basic fundamental concept of probability, right? Where the number of event A divided by the number of total possible outcome or sample space, right? So today we're going to look into the law of probability and some rules, right? So there are 4 rules that we're going to look up, right? The first rule is a rule of addition. So rule of addition says that when we have the probability of A or B, right? Probability of A or B is equal to probability of A union B, right? Where probability of A union B is equal to probability of A plus probability B minus probability of A intersect B. So this is the general formula or rule for addition, right? So whenever you have the word or, it means that you're going to do probability of A union B, right? Right, let's continue. Probability of A union B is equal to is also equal to probability of A or probability B, right? So another rule in addition, when you have a mutual exclusive event, right? So when you have mutual exclusive event, then if you want to find probability of A or B, it means that probability of A union B equal to probability of A plus B. Because if you still remember, for mutual exclusive event, if A and B are mutual exclusive event, so the probability of A intersect B is equal to 0, right? Boleh? Alright. So as I said previously, when you have mutual exclusive event, right? Mutual exclusive event, the probability of A intersect B should be equal to null set, right? So since probability of A intersect B is equal to null set, so originally we need to minus probability of A intersect B, right? So when probability of A intersect B is equal to 0, so it will left us probability of A plus probability B. So this is a rule of addition, right? So no matter how whether the event is not mutually exclusive or mutually exclusive, I think you just need to remember one formula only. This formula number 1, which is probability of A union B is equal to probability of A plus probability B minus probability of A intersect B, right? So if the probability event A and B are mutually exclusive, so this one is automatically become 0, right? Okay, so this is a formula for rule of addition. And for complement rule, right? Complement rule, as we know that the total of all probability is equal to 1, right? So if you want to find probability of A complement, right, so this one should be equal to 1 minus probability of A, right? So this is the complement rule. And then we have a rule of multiplication. So for rule of multiplication, they are divided into 2. The first one is when A and B are independent event. Another one is A and B are dependent event. So we have 2 formula here. This is 1, this is 2. Right. If A and B are independent event, so if you want to find probability of A and B, right? Means that you want to find probability of A intersect B, right? So probability of A intersect B is equal to probability of A multiplied with probability B. This is for A and B independent event. Means that A is not related to B. That means when let's say for example, let's say in tossing a coin, right? When you toss a coin for the first time, you got head, right? The second time you toss a coin, right, and you got tail, right? Adakah maksud the second one you dapat tail tu disebabkan pertama tu you dapat head? No, right? Because it's completely not related, kan? So that is an independent event, means that they are not related event, right? For dependent event means that we want to find a probability of A when probability of B is already occurred. Means that let's say I go to that one restaurant. This one restaurant has been baru buka dekat town. So I pergi makan dekat situ. Okay, this restaurant is having a good food, right? Very nice food. So I balik rumah, I bagi tahu dekat Ali contoh, right? So now we want to know. Sekarang ni I sudah pergi ke that restaurant. My event is already occurred. So we want to know the probability that Ali will go to that restaurant provided that I dah bagi the information. So this is what we call as dependent event. So we want to know the probability Ali will go to that restaurant disebabkan I dah bagi tahu dia the food is good. Faham tak? So that is what we call as a dependent event lah. So for dependent event, right? For dependent event, probability of A union intersect B, right? Probability of A intersect B is equal to probability of B multiplied with probability of A given B, right? So the original formula we will find it in a conditional probability. This is what we call as conditional probability, right? Conditional probability. So means that this case, it means that probability of A given that B is already occur. So the stroke here called as given. So B here is the probability of our event that already occur, yang sudah berlaku. When A is the probability that we want to know, right? So cara baca dia probability of A given B, right? Masuk dekat sini, B is the event is already occur, sudah berlaku. We want to know, in this case, we want to know what is the probability of A given that B is already happen. Macam contoh saya bawa tadi lah, right? I dah pergi makan that restaurant. I sudah berlaku, this event sudah berlaku. So I bagi tahu dekat Ali. So Ali punya, we want to know what is the probability Ali akan pergi that restaurant. Right, this is what in the mathematical form, this is what we call as conditional probability. Right, so or kalau kita tengok the formula keep on changing. So this is what happened. I can explain why. So probability of A intersect B is equal to probability of B multiplied with probability of A given B. And probability of A intersect B is also equal to probability of A multiplied with probability B given A. Right? This is why. This is because we just do a manipulation lah from a conditional probability. Probability of A given B is equal to probability of A intersect B divided by probability B, or probability of B given A equal to probability of A intersect B divided by probability of A. you can see the difference here. So bila B sudah berlaku, so B will be at denominator. A sudah berlaku, A will be at denominator. So what happened here, macam mana I dapat this formula, the first formula here, because let's say I change the color to green. Right, because I do some manipulation. So I bawa ni ke sini. So probability of B multiply with probability of A given B is equal to probability of A intersect B. Right? And this one sama juga. Probability of A multiply with probability B given A equal to probability of A intersect B, which is, this is our same lah. Number 2 also same. So this is what we call, this is a formula of when we have a dependent event, and this is a formula when we have independent event. So I hope you can understand and differentiate when A and B are independent and when A and B are dependent. Like, so now let's look at example number 3.37. 3.37. In a survey, 15% of the participants says that they have never bought a laptop, right, or a tablet PC. Means that this one, probability of laptop union never bought, kan, laptop complement tablet complement is equal to 0.15. And then let's look at the next statement. 73% bought laptop. Maksudnya dekat sini, in this case, probability of L is equal to 0.73. Right? And then 49% had bought tablet PC. So it means that here, probability of T tablet PC is equal to 0.49. Right. Find the probability that a person chosen at random from those who taking part in the survey had bought laptop or tablet PC. So this one, we want to know probability of laptop or tablet PC. Okay. So by using a complement rule, right? So one, we already know the probability of not buying laptop or not buying tablet PC. 1 minus probability of L complement union T complement. So it should be 1 minus 0.15. Then it should be equal to 0.85. And next one is probability of laptop and tablet, right? So we need to understand buying laptop and buying tablet is totally is it independent event or dependent event? We cannot say, right? We cannot say. Right. Sometimes people buying tablet because they already have a laptop, right? We cannot say. So we don't know. So if you don't know, so we need to use whatever information we have here. So whatever information we have here, first is probability of L. Probability of L complement T complement. Probability of T. Probability of L union T. So since we already have, we want to find probability of L intersect T, so we will use this formula. Probability of L union T is equal to probability of L plus probability of T minus probability of L intersect T. So dekat sini, this is what we want, right? So probability of L in union T is equal to 0.85. Probability of L is 0.73. Probability of T is 0.49 minus probability of L intersect T. So you can do a manipulation. So probability of L intersect T should be equal to, you bring all these together, bawa ke sana, and you should get berapa dekat bawah ni? Wait, I think there's something wrong with the correct. So they just bawa yang ni ke sini, ini ke sana lah. Right, so it should be 0.37. Right, good. This one should be 0.37. Right. Okay, the last one is bought a laptop only. So when you want to find probability of buying a laptop only, means that probability of laptop minus probability of, so why I got this answer. So let draw the Venn diagram, right? So Venn diagram dekat sini. So let's say this is a sample space and we have two event, where this is a event of buying a laptop, this is the event of buying a tablet, right? So now here, the whole thing here dalam bulatan ni, this is the probability of buying a laptop, and the whole thing here is the probability of buying tablet, right? So, kalau you nampak, so probability of buying laptop is 0.73. Probability of buying tablet only is 0.49. And we know the probability of intersection is 0.37. Here, kalau kita ada probability of buying laptop, this one, probability of buying laptop, dia ada sedikit orang yang beli laptop dan tablet juga. Sebab dia ada intersection. The whole thing 0.7573 ni termasuk dengan beberapa orang yang beli laptop dan tablet. So what we want to know, people that only buy laptop sahaja, tak beli tablet langsung, laptop sahaja. So to get this answer, we need to find the pink area. So to find the pink area, probability of L, which is buying a laptop as a whole circle here, minus this part, the intersection, probability of intersection L and T. That's why 0.73 minus 0.37. So you will get 0.36. Okay. So let's look at example number 3.38, right? So a group of 50 people was asked which three magazine, X or X, Y, Z, right? They are read. The result shows that 25 read X, 16 read Y, and 14 read Z, right? So kita ada information ni. And then we also know 5 read both X and Y, 4 read, this is BC, I think the X, Y, Z. So dia guna BC. This is going to be Y, and this is Z, this is Z, and X. Okay, boleh? So 4 read X, Y, and Z. 6 reading Z and X. 2 are reading all 3 magazine. So here they ask us to draw a Venn diagram. So kita buat satu gambar raja Venn yang besar. So we know that there are intersection of 3 magazine, right? So they're going to be intersection of 3 magazine. So dekat sini ada satu lagi. So this is X, this is Y, and this is Z. Area here represent apa? This area will represent the intersection of all 3 magazine, right? Betul? So kita tahu the sample space we have 50 people. So there are 2 people are reading all 3 magazine. So we will put 2 dekat sini. So this is going to represent 3 magazine. Alright. And then kita pergi one by one. So kita ambil ini. 6 are reading Z and X. So Z dekat sini, X dekat sini. Z dekat sini, X dekat sini. So 6 are reading X and Z. So 6 dekat sini kita color dulu. So bagi nampak color dia. So color dia termasuklah dengan green kan. So this is what we call as the intersection between Z and X. So ada 6 orang. So 2 orang dekat sini, tinggal balance 4. Okay. And next, kita boleh buat lagi satu. Y and Z. Y and Z dekat sini lah. So this is Y and Z. On the right hand side ni. So ada berapa? 4. So 2 dekat sini, 2 lagi kat sini. Right? And then 5 are reading both X and Y. So 5 are reading both X and Y. Right? So X and Y, 5 dah ada dalam tu, 2. So 3 dalam sini. Right? And then dia kata kat sini 14 are reading Z. 14 are reading Z. So 14, let's say I color this one. So 14 Z dekat sini lah I color with the green color sekali. Right. So 14 termasuklah dengan 4, 2 and 2. Right. It should be berapa tinggal? 8, right? Is it? Is it 8? No. It should be berapa? 6. Right? So 6 plus 4, 10 plus 2 plus 2, 14. Right? So then 16 are reading Y. So still the same process. 16 kita ambil the area dekat sini. So 16 tolak dengan 3, tolak dengan 5, dengan 11, tolak dengan ni, dengan berapa? 9. Right? So this area should contain 16 people. Right? And then the last one is 25. 25 are reading X magazine. So we color X magazine. Okay, X magazine here. So 25 minus 4, 25 minus 5 minus 4. So should be equal to 16. Is it? Can you calculate for me? Right. So now, what is the total of people who read all the magazine? Berapa orang dekat sini? 16 plus 5 plus 4 plus 9 plus 2 plus 6. There are 42 people are reading this magazine, either X, Y or Z or both. Right? So kita ada people berapa dekat sini? 50. So there are 42 50 minus 42. So there are 8 people are not reading any magazine. So this is how we construct a Venn diagram. Okay? Right. Let's look at example for your final exam question. Kalau boleh tengok. Tak apa. Nanti kita masuk conditional probability dulu. Right. So then baru you boleh faham. Okay. Conditional probability. As I said just earlier, conditional probability is the formula for conditional probability is probability of A given B equal to probability of A intersect B divided by probability B, right? So probability of A it cannot be 0, and probability B also cannot be 0. Okay, so probability of B given A is also equal to probability of A intersect B divided by probability A, and probability of B cannot be 0, right? Okay, that is the formula for conditional probability, and we already understand. I already explained to you the form. What is the meaning of this formula? It means that probability of A, I explain again, given B, A given B, means that B is event already happened, and this is the probability that we interested to know, right? This is the event that we interested to know, and this is the event that already happened. So this one should be probability of A intersect B divided by probability B. Sebab kita tengok dekat sini B dah ada kat belakang, so dia akan duduk dekat bawah. So if you want to find the other way around, probability of B given A, it should be equal to probability of A intersect B divided by probability of A. So A dekat denominator. So this A is already happened. We are interested to find probability B. Okay. So this is what conditional probability all about. So let's look at kita skip this example. Dia kita akan masuk. So now kita tengok dia punya important dulu, and then kita combine all the knowledge together, dan baru kita jawab soalan. Right. So independent event, as I said before, when probability of A intersect B is equal to probability of A multiply probability B, and this is, then we can say that A and B is independent event. Right. When you get A intersect B is not equal to probability of A multiplied with probability B, then we can say that A and B are dependent event, right? So when A intersect B equal to probability of A multiply B, only at this case, then we can say that A and B are independent event, right? Okay, boleh ya? This is a simple concept. Now, let's look at this example. Probability of event A, example number 3.42. So we have A and B are independent event. It's already tell us A and B are independent event. So they give us probability of A is equal to 1/3. And then probability of A intersect B is equal to 1 over 12. Right. So they ask us to find probability A and probability B. So since probability of A and B are independent events, so A intersect B should be equal to probability of A multiplied with probability B. That's the rule, right? So probability of A intersect B is 1 over 12 equal to probability of A is equal to 1 over 3, and this is probability B that we want to find. So we just do a manipulation, simple manipulation, bawa ni ke sana, right? 1 over 3 bawa ke sana, and then we will get probability of B is equal to 1 over 4. Okay. Boleh? And then if you want to find probability of A union B, right? So since we already have the value probability B, A and A intersect B. So if you want to find probability of B union A is equal to probability of B plus probability of A minus probability of A intersect B. So this is a straightforward. So we just input the value dalam formula. This one should be 1 over 3 minus 1 over 12. So this one should be 1 over 2. So this is simple, right? Just plug in the value into the formula, right? So kita skip this one. You boleh baca sendiri because I already give you the answer. Right? We will focus on final exam question. So now, let's look at the probability tree diagram. Probability tree diagram, it means that we want to draw a tree diagram. So instead of this is another way of getting all possible outcome. Instead, we calculating by using a counting rule, right? This is one method. Another method is by drawing a tree diagram, right? So kita dah tengok hari tu counting method, and then kita tengok Venn diagram, and now we will see about tree diagram, right? So tree diagram is look like this, right? Let's say you toss a coin 2 times, right? So you want to know how many possible outcome. By counting rule, we already know for the first step, we toss a coin 2 times. For the first toss, we have 2 outcome, either head or tail. For the second toss, we also have 2 outcome. By using theorem 1 in counting rule, 2 multiplied with 2, we should get 4 possible outcome, right? So what are the outcome? So to display or to construct all to know what is the outcome, so we can draw a tree diagram. So first draw, kita ada 2 outcome. So dia pecah head or tail. This is a first toss. If the first toss you got head, the second toss you still have 2 outcome, head or tail. Are you with me? Right? If the first toss you got tail, the second toss you also have 2 outcome, head or tail. So this one will represent head. This is going to be head and tail. This is tail and head, and this is tail and tail. So this is a tree diagram. The probability tree diagram is where we impose a probability value on the tree diagram. So the probability, let's look at the first toss, right? At the first toss here. Dekat first toss ni, I bagi besar sikit. Right, kita nampak clear. Okay, at the first toss, we have 2 outcome. The probability of getting head is 1 over 2. And probability of getting tail is also 1 over 2. Right? For the second toes, the probability of getting head is 1 over 2. Probability of getting tail is also 1 over 2. This one, 1 over 2, 1 over 2. Right? So now, let's know the notation inside the tree diagram, probability tree diagram here. So this is the first toes, 1 over 2. It means that we have a probability of getting head. This is also represent probability of getting tail. When the first toes is already happened, we got the first toes. Let's say we got head, right? Head is already happened in the first toes. The second toes we got head. So this represent probability of getting head given that the first toes is head. And this one will represent probability of getting tail given that the first toes is head. This one represent probability of getting head here given that the first toes is tail. And this one will represent probability of getting tail given that the first toes is tail. Boleh faham the notation? This is a probability tree diagram. Okay? So let's look at the question in final exam question. Okay, kita tengok question ni. Okay, in a factory, machine A, oops, terlalu besar. Machine A, B and C are all producing metal rod of the same length. Machine A produced 35% of the rod. Machine B produced 25% of the rod, and the rest are produced by machine C. Right? Remember, in probability, the total of all probability should always equal to 1. Right? This is what you need to remember. So now, let's draw the first three. So we have 3 machines. Right? We have 3 machines. This is a machine A, this is machine B, and this is machine C. Right? Machine A produce 35%, which is 0.35. Machine B produce 25%, 0.25. Machine C, 1 minus 0.35 minus 0.25. So this one should be equal to 0. What? Berapa? 0. Berapa nilai dia ni?
0.4.
0.4. Right. So we complete the first phase. Right. Now we look at the second phase. Second statement, dia kata apa? Of their production rod, machine A, B and C produce 3%, 6% and 5% defective rod respectively. So we know that dia akan produce goods, rods kan. So there will be 2 type of rods, either the defective rod or effective rod. Maksudnya rod yang okay and rosak. So there will be 2 outcome, defective, non-defective. Defective, non-defective, because all is producing the same thing, right? Defective, non-defective. So now for machine A, 0.03 are defective. Machine B, 0.06 are defective. Machine C are 0.05 defective. And for non-defective, this one should be 0.97. or complement of the effective 0.04 sorry 0.94 0.95. Okay, so what does it mean here? We know that from the tree diagram, this is probability of A, and this is probability of B, and this is probability of C. This is probability of D given A. This is probability of D complement given A. And this is probability of D given B. So I hope you get the idea, lah, right? This is probability of D complement given B, and this is D given C. This is also probability of D complement given C, right? I hope you get the idea. So this is probability tree diagram, right? Let's look at our content. Okay, so this example I skip, then you can follow by yourself lah. So let's look at Bayes theorem, which is the last part of this topic. Right, Bayes theorem is the key to almost any procedure for extracting information from data. Right, so when you want to do a naive Bayes machine learning, so you will use Bayes theorem. When you want to use support vector machine, you also employ Bayes theorem. You want to use random forest, you also employ Bayes theorem. Basically, all of the method are using Bayes theorem when there is a independent event. Kalau ada dependent event, Bayes theorem will be the main reference, right? So now, to understand Bayes theorem, first we need to understand theorem number 11. So theorem number 11 says that if event A1, A2, A3 until AK constitute a partition of the sample space S, and probability of AI is not equal to 0, right, for any event X in S, any event A in S, right? So betul lah event X in S, right? So if you want to find probability of X, right, so we need to sum this value, or let's focus on this one. We need to sum all the intersection with A with X, right? If you want to find probability of X, we need to sum all the intersection with X. For example, let's say I have a lake here, satu district, a sample space, right? I have a whole banyak district dekat sini lah. Satu negeri lah. This is a one state. So I have very big lake in this state, right? So dekat lake ni dia share dengan district number 1, and they also share with district number 2, and also share with district number 3 and district number 4, right? So let's name this lake as A, right? You nampak? So if I want to compute how big this A, right? So what I need to do is I need to add this area on the district 1. I kena dia ada dekat sini kan. Okay, I tunjuk. This is the area of the lake dekat district 2. Let me color for you to see clearly. And then this is the area for D3, lake for district number 3. And the last one is, this is the area of district area of the lake for district 4. Right? So kalau you nak cari A, you kena tambah semua intersection. So this is the intersection. This is A intersect D1. And this is D2 intersect A. This is D3 intersect A. And this is D4 intersect A. Right? So kalau you nak cari A, means that you need to add all the intersection with A. Right? This is what the formula tell us lah. So I just explain in a pictorial view. Right? So you got the idea, right? So this is what the theorem number 11 try to tell us. If you want to find A, you need to add all the intersection with A. If you want to find X, you need to add all the intersection with X. So this is what theorem number 11 try to say, try to explain to us. So once you already I tulis dah kat sini, okay, right? So I explain to you. So if you don't understand, you can read further. Now, let's look at the example. So example question 6A1 kita dah buat. So now let's look at question 6A2. So what is the probability of that a randomly selected rod is produced by machine A is defective? Right. So what is the probability? The rod is produced by machine A. So probability of produce of machine A is defective. Maksudnya A intersect D. Allah. Yang kita nak cari dekat sini adalah A dan defective. Maksudnya we want to find probability of A intersect with D. So this one should be equal to 0.35 multiply with 0.03. So this one should be equal to how much? 0.35 multiply 0.03. What is the answer? Zero point 0.0105, right? Is it? Okay. Now, let's look at number 3. Find the probability that randomly selected rod is defective. So, we want to find probability of D. This is where theorem number 11. So, we already have the probability of A. We know the probability of A. We know probability of B, C. But we don't know probability of D. In the tree diagram, it gives us probability of D given A. It's not probability of D. So, based on theorem number 11, if you want to find the probability of D, you need to add all the intersection with D. So, how many intersection with D we have? We have probability of A intersect D. We have B intersect D. We have C intersect D. Right? So we need to add all the intersections. So the first one is probability of A intersect D plus probability of B intersect D plus probability of C intersect D. So this one should 0.03 multiply with 0.35 plus, can you calculate for me? 0.06 multiply with 0.25 plus 0.05 multiply with 0.4. So what is the answer?
Zero
0.0455. Right. Okay, good. So now, before we move to the next question, let's look at the Bayes theorem, which is theorem number 12. Where is it? Alright. Theorem number 12. So this is a Bayes theorem. So if event A1 until AK constitute a partition of sample space S and probability of AI is not equal to 0 for any event X in S and probability of X is not equal to 0, if you want to find probability of AR, for example, given X, it should be equal to probability of AR intersect X divided by summation of probability of AR intersect X. This one, the denominator ni, maksudnya apa? This we are adding all the intersection with X, right? So this is actually probability of X. This is what Bayes theorem try to tell us lah. Basically, it will stick to the original conditional probability. Probability of A given B is equal to probability of A intersect B divided by probability B. So, you nampak tak? So, if you look at this one, so this sepatutnya sama dengan probability of X. And this one, probability A intersect X. Benda yang sama. Right? So, basically, that's why before we try to understand Bayes theorem, we need to understand theorem number 11. So this is what we call as probability of X, because we are trying to add all the intersection with X. Okay, so basically that is Bayes theorem lah. So kita tengok sini, right? So now, given that a randomly selected rod is defective, so try to do this notation. Dia kata dekat sini, given the selected rod is defective, right? So find the probability that it was produced by machine C. So kalau you tengok dekat sini, the formula that you have, you don't have given D, right? So apa yang you ada? D dekat depan, right? And then you already calculate probability D, right? So now, to find probability of C given D, it should be equal to probability of C intersect D divided by probability D, right? So probability of C intersect D should be here, 0.4 multiplied with 0.05 divided by probability D, which is here, 0.0455. So you can get the probability of C given D. Boleh faham? So what is the answer?
0.44.
0.44.
Yeah.
Okay, good. Alright. So basically, today we already learned the rule of probability, the rule of addition, rule of multiplication, rule of complement. Rule of addition, we already know two type of addition rule, where when A and B are independent, and A and B are mutually exclusive, or A and B is not mutually exclusive. For independent event, multiplicative rule, there are two formula we already learned. When A and B are independent, another one is A and B are dependent. So when A and B are dependent, we are taking from conditional probability. We also learned conditional probability equal to probability of A given B is equal to probability of A intersect B divided by B, probability B. It is vice versa lah. And then we also learn Bayes theorem. But before we understand Bayes theorem, we need to understand theorem number 11, which is I already explained to you. So basically that's all for chapter number 3, right? So all these example you can do by yourself. Now let's look at this question before we end our session. We try to do all the question. Now this is your past year question. I'm not sure, 2014 I think, right? So 4-digit number to be formed from a digit 0, 1, 2, 3, 4, 5 and 6 without repetition. So this is, they already clear out without repetition. How many number can be formed if each number less than 5,000? So dia nak form 4-digit number, and this number should less than 5,000. Maksudnya it should be either 4,999 and below, right? 4,999 and below. So the first number here should be only 4. So dekat sini dekat 1 saja. So how many number we have? 1, 2, 3, 4, 5, 6, 7. So we have 7. So we already pick 1 dekat sini. So kita tinggal 6 lah. Right? 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6. Kita tinggal 6. And then the next one should be 6, 5, 4. So by using theorem number 2, 1 multiply with 6, multiply with 5, multiply with 4, it should be how much?
120.
120.
20.
Yep, good. So this one should be 120. Should be very simple because it's 2 marks. Right. Now let's look at B. Right. This is a question to recap whatever we have learned today. So we have probability of A is equal to 2/3, probability of B is equal to 3/10, and probability of A given A complement, B given A complement is equal to 1/3. So we want to find probability of A union B. So probability of A union B, tapi dia dekat sini tak bagi tahu sama ada A is not mutually exclusive or not, right? So probability of A union B is equal to probability of A plus probability B minus probability of A intersect B. But we don't know the value of A intersect B. We only know probability of A, B. And we don't know probability of B given A complement. We also know probability of A given complement. Given A complement. So let's expand this formula. B given A complement, it should be equal to probability of A complement intersect B. Ataupun kalau you suka, probability of B intersect A complement. This is idempotent law, benda yang sama. Associative law ke idempotent law, I don't remember. Divide by probability of A complement. Right? So still not solving our problem, because we don't know the probability of A intersect B, right? So but we know probability of A complement intersect B, right? So let's focus on A complement intersect B. So I bawa tepi sikit sekejap. So if we cannot confirm what is the formula for A complement intersect B, we can always refer to Venn diagram. So always refer to Venn diagram. Right? So Venn diagram, we have A, let's say this is A and this is B. A complement, where is the A complement? Ini besar sangat lah, nanti habis ink I. Kecilkan sikit. Kecilkan sikit. Yes. Alright. Let's say I highlight A complement. This is outside A is A complement, right? Including B. Right. This is yang bulatan ni adalah A, yang luar daripada bulatan ni adalah A complement. So this is all A complement. Right? You got the idea, right? So intersect with B. So where is B? This is B. A complement intersect with B. So the whole circle here is B. So you notice the different color. So the color that intersect, you faham the concept of color, blue plus yellow should be equal to green. Right? So the color overlap should be green, kan? So this is the intersection. A complement intersect B. Boleh faham? Which is this area only. Yang nampak ni, yang sekerat ni dengan ni. So how to find this one? How to find this one? To get this area, right, I highlight satu lagi color. Kau tak nampak kan? This area. This area. To get this area, the green area ni, mana dapat? Probability of B minus the whole B ni kena minus dengan this one. The blue color, the blue area. The blue area is probability of A intersect B. This is how we expand the formula. At first, you nampak macam susah. When you do a lot of practice, then I don't think it is going to be susah already lah. It should be very easy. Right, so we can convert this to this. So probability of B minus probability of A intersect B divided by 1 minus probability of A is equal to probability of B, probability of B given A complement. So now we can see the thing that we want, right, which is probability of A intersect B. Then now we just substitute the value. 1 over 3 is equal to 1 B intersect given A complement. Probability of B is equal to 3 over 10 minus probability of A intersect B divided by 1 minus probability of A is equal to 2 over 3. So now we can find probability of A intersect B, right? So what is the probability value for probability of A intersect B? So what is the value? One minus 1 over 3 is equal to 1 over 3, right? So bawa ke sana. So 1 over 3 multiply with 1 over 3.
1 over 9.
Right? So, and then you bawa this one ke sana. So 1 over 9 minus 3 over 10 equal to negative probability of A intersect B. Right? So 1 over 9 minus 3 over 10. It should be equal to 17 over 90 equal to probability of A intersect B, which is also equal to 0.189. So now you already have the value. Just plug in the value into the formula. So 2 over 3 minus 3 plus 3 over 10 minus 17 over 90. Right?
It's 7 over 9.
7 over 9. Right? Or 7 over 9. You just make it a fraction apa, okay. Right? So that's all. Kita dah dapat this one. Also got 17 over 90. And probability of A given B, B given A is probability of A intersect B divided by probability of A. You just plug in the value 17 over 90 divided by probability of A is equal to 2 over 3. So you will get this one. And then probability of A and B are independent event. So probability of A intersect B should equal to probability of A multiplied with probability B. So what is the value probability A multiplied B? 2 over 3 multiplied with 3 over 10. It should be equal to 1 over 5.
1 over 5.
So 1 over 5 is not equal to 17 over 90. So then we can say that A and B are not independent event. Right? Very simple. Okay. Let's look at the last question for today. Right. This is about a Bayes theorem and tree diagram. Okay, kita tengok sini. The student at local university have registered their subject online. Last semester, 20% of the student use cyber cafes. 50% of the lama tak dengan cyber cafe. Right, 50% of use their personal computers and the rest use laboratory computers to register online. Right? So dekat sini 50% of use, okay, kita biar dulu, kita tengok yang ni dulu, this area, this statement dulu. Right? Because they want us to create a tree diagram. Kalau dia tak suruh pun, you kena buat tree diagram. Kalau tak, you tak nampak the whole picture. Right? So you have three medium yang student guna. First is cyber cafe, and this is a personal computers, and the last one is laboratory. Alright, laboratory. So cyber cafe is 0.20, personal computer is 0.5, and the rest is berapa? How much? 1 minus 0.7, 0.3. So this is the first part. Right, now let's look at the second part. The second part, 50% of those who use cyber cafe fail to register on time. Maksud dekat sini, they're going to give you two options. Either register on time or not register on ataupun late. Like say kita letak satu statement lah, late or on time. So kita letak L for late, L complement for on time. So you need to put the notes lah. C is for cyber cafe, L is for late, L complement for on time. So then baru you boleh faham apa yang you buat. Right? Always do this habit lah. Jangan buat macam you terror. You learn, you try to make it all notes dekat bawah. So you tak lupa. Right? So you have L and L complement. L. Oh, we already have using L kat sini. So jangan ada overlap. So dekat sini laboratory So we cannot use L lah. Sebab L sudah diambil kan. Kita letak L untuk laboratory. Let's say kita guna O lah. O for on time. So we have O complement, O complement, O and O complement. Right, dia kata dekat sini 50% of those who use cyber cafe fail to register on time. So fail to register on time, O complement 0.5 and on time is 0.5. For those who use personal computer, only 10 fail to register on time. Personal computer 0.1 is fail to register on time. 0.9 is on time. 20% who use laboratory computer also fail to register on time. So 0.2, 0.8. Right. I hope you already understand the notation. I don't want to write down again the notation. So now, number 2, calculate the probability that student chosen at random from university fail to register on time. Maksudnya, we want to know O complement. Right. So if you want to know O complement, you need to add all the intersection with O complement. Right? Add all intersection with O complement. This one should be 0.2 multiplied with 0.5 plus and 0.5 multiplied with 0.1. This is 0.1, right? 0.1 plus, and the last one is 0.3 multiplied with 0.2. Right, so what is the answer here?
0.21.
0.21. Right, so now 0.21, simple, right? 3 marks for you. And then the last one, I don't know the correct answer. You calculate for me, right? Because I just take whatever answer you give. So given that the student registered on her subject on time, maksudnya kita letak macam ni. So probability, given that they register on time, so given O, right? What is the probability that she used personal computer to register? So personal computer is P. So this is what we want to find. Probability of P given O, which is equal to probability of P intersect O divided by probability of O. So probability of P intersect O is, let's say I use this color. So P intersect O dekat sini, the blue color, right? So this one should be 0.5 multiplied with 0.9 divided by probability of O. We don't need to calculate all again, right? We just need to use our knowledge on complement probability, complement rule. So 1 minus 0.21. So what is the answer?
0.79.
0.79, right? Okay, I think that's all. Betul ke?
No, sir. 0.79 for 1 minus 0.21.
Oh, yang atas tu. Alright.
Yeah.
0.5 multiplied with 0.9 divided by 1 minus 0.21. It should be equal to 0.57.
7.
Right. So I think that's all. Do you have any questions so far? So basically we already finished chapter number 3. Right. So I ada soalan dekat sini, you boleh buat benda yang sama juga. So in this this is an example of I think 2015, right? So dia letak bar dekat sini, it means that this is a complement lah, right? Is also equal to probability of A given B complement. Benda yang sama, this is a complement, right? Okay, ada soalan before we end our session? Ada soalan?
I don't think so.
Okay, if you don't have question, then I think that's all for chapter number 3. And Assalamualaikum.